Picture this, a world where the sky rains acid, where the atmospheric pressure could crush a nuclear submarine, where the surface temperature melts like butter on a hot skillet. This is Venus, Earth's evil twin. 900 degrees Fahrenheit, 92 times Earth's atmospheric pressure. Clouds of sulfuric acid are so thick that sunlight barely penetrates. And yet, between 1961 and 1984, the Soviet Union didn't just visit this nightmare world, they landed on it 10 times. 8 of those missions sent back data. But here's what haunts scientists to this day. What did those probes find? 5 discoveries that defy explanation. And decades later, we still don't have all the answers. These probes had operational windows measured in minutes, sometimes hours if they were lucky. Venera-13 holds the record. 127 minutes on the surface before the heat finally won. That's over 2 hours transmitting images and data across 25 million miles of space. Let that sink in. In 1982, Soviet engineers built a machine that survived longer on Venus than most people could hold their breath. No nation has landed on Venus since 1984, not the United States, not China, not even modern Russia. Discovery number 5, the snow on Venus. In 1983, Venera-15 and 16 weren't landers, they were orbiters equipped with synthetic aperture radar. Their mission, map Venus's highlands with unprecedented detail, and they found something impossible. Above 8,000 feet, Venusian mountaintops glowed bright white on radar imaging, highly reflective, consistent across multiple peaks. It looked exactly like what you'd see on Earth's mountains. Snow, except Venus is 900 degrees Fahrenheit. Water ice would vaporize in milliseconds. The leading theory, metallic frost. At Venus's hellish surface temperatures, certain heavy metals vaporize. Lead sulfide, bismuth sulfide, then condense on cooler highland peaks like frost on a winter morning. It's chemistry straight out of a nightmare periodic table. But here's the problem. When scientists tried replicating this process in laboratories, they couldn't match the radar signature. The reflectivity is wrong. The distribution patterns don't line up. One Soviet geochemist put it this way: it's like Venus has its own rules for how matter behaves. 40 years later, we still can't explain the snow that shouldn't exist. Discovery number 4, the moving rocks. Venera-13 and 14 landed in 1982, just months apart, in different regions of Venus. Both carried panoramic cameras, spring-loaded mechanisms that captured 180-degree surface views in sections. The images were stunning. Flat volcanic plains, jagged rocks, alien geology frozen in amber light. But in the 2010s, when planetary scientists began digitally restoring these images with modern software, they noticed something disturbing. Rocks that appeared to have moved. One object, nicknamed the Scorpion by researchers, showed clear morphological changes between image sequences captured just 2 hours apart. Comparative analysis suggested genuine displacement, not camera artifacts. Now, Venus's surface winds are glacial, 2 to 3 miles per hour, not nearly enough force to move rocks. So what happened? Camera lens cap interference? Maybe, but computer modeling says unlikely. Volcanic tremors? Possible, but no seismic activity was recorded. Surface weathering in 2 hours? In 2012, Russian geologist Leonid Ksanfomality published a paper suggesting, controversially, that the changes might be biological. Something moving, something alive. The rocks of Venus remain an open question. Discovery number 3, the lightning that shouldn't exist. Lightning on Earth is a well-understood phenomenon. Water droplets collide in storm clouds. Friction generates static charge. Discharge. Lightning. Simple. Predictable. Physics 101. Venus has lightning too. Lots of it. Multiple Venera missions detected electromagnetic bursts consistent with electrical discharge. The 1978 Pioneer Venus orbiter confirmed it. Massive, sustained electrical activity throughout Venus's atmosphere. But Venus has a problem. There's no water cycle. The clouds aren't water vapor. They're sulfuric acid. The atmospheric chemistry is completely different. By Earth's rules, Venus shouldn't have lightning at all. Yet it does, and it's more intense than Earth's. In 2020, NASA's Parker Solar Probe performed a gravity-assist flyby of Venus. Its instruments detected Whistler waves, electromagnetic signatures that only form from lightning. The frequency was higher than anything recorded in Earth's atmosphere. Current theories are all over the map. Maybe sulfuric acid chemistry creates different electrical dynamics. Maybe volcanic ash plumes generate static discharge like terrestrial thunderstorms. Maybe there's atmospheric chemistry we can't replicate in labs. But here's why it matters. Lightning chemistry can create organic molecules, the building blocks of life. If Venus has sustained electrical activity in an exotic chemical environment, it might be cooking up prebiotic compounds we've never seen. The lightning storms of Venus aren't just beautiful, they're potentially biology's laboratory. Discovery number 2, the impossible survival time. Venera-13 descended through Venus's atmosphere on March 1, 1982. Soviet engineers expected 32 minutes of operational time, maybe 45 if they were lucky. The probe transmitted for 127 minutes, nearly 400% beyond design specifications. It's the equivalent of a smartphone designed for an hour of battery life suddenly running for 4 hours in an oven set to broil. Post-mission analysis was baffling. The environmental data showed the landing site was hotter than predicted, not cooler. There was no thermal anomaly that would explain extended survival, no equipment malfunction that accidentally improved cooling. Something about Venus's surface allowed better heat dissipation than Soviet models suggested. Some scientists propose microclimate variations, localized atmospheric circulation or subsurface cavities creating cooling zones. Others wonder if Soviet engineering was simply decades ahead of publicly acknowledged capabilities. But here's the modern implication. NASA's Da Vinci mission, launching in 2029, is being designed with thermal models partially inspired by Venera-13's mysterious endurance. If we can understand why that probe survived so long, we can revolutionize future Venus lander design. 40 years later, Venera-13 is still teaching us lessons about survival in hell. Discovery number 1, the phosphine debate's Soviet connection. September 2020. Scientists announced the detection of phosphine gas in Venus's atmosphere. Media explosion. Life on Venus. Phosphine is a potential biosignature. On Earth, it's almost exclusively produced by biological processes or industrial chemistry. Finding it on Venus was staggering. But there's a detail most people missed. Venera-12, which landed on Venus in 1978, carried a gas chromatograph, an instrument designed to analyze atmospheric chemistry. When modern researchers re-examined the original Soviet data, they found something buried in decades-old readouts: anomalous chemical signatures, compounds that didn't match volcanic models. During the Cold War, Soviet scientists flagged unexplained organic chemistry in the lower atmosphere. The data was classified. Then, when the USSR collapsed in 1991, it was forgotten. Until 2020, when the phosphine announcement made headlines, planetary scientists started digging through Soviet archives. What they found suggested that Venus's atmosphere has been chemically weird for at least 50 years, possibly longer. If phosphine was detectable in 1978, why wasn't it recognized? Possible answer: Soviet instruments weren't calibrated to identify it as significant. They recorded the data, flagged it as anomalous, and moved on. The controversy? The phosphine detection has been disputed, reconfirmed, and disputed again. As of 2024, the scientific community is still debating whether it's real. But Soviet-era data doesn't lie. Something strange is happening in Venus's atmosphere, and we've been ignoring it since the Cold War. That's why it's discovery number 1. Now here's the part they don't put in textbooks. When the Soviet Union collapsed in 1991, thousands of Venera data tapes went missing. Literally missing. The Russian space agency, Roscosmos, has only managed to digitize about 40% of the original mission data. The rest, scattered across research institutes, stored in forgotten archives, some destroyed, some lost forever. During the Cold War, Western scientists had almost zero access to raw Soviet data. They relied on published papers, carefully curated, politically filtered, translated summaries. The full picture was never shared. And there's a darker twist. Declassified NASA memos from 2015 reveal that US Venus missions in the 1990s, missions like Magellan, were explicitly designed to validate or refute Soviet claims, not collaborate, compete. Here's the uncomfortable question. Did Cold War rivalry cause humanity to ignore our closest planetary neighbor for 40 years? In the 2010s, a new generation of planetary scientists, people who didn't grow up with Cold War paranoia, started digitally restoring Soviet-era images using modern processing techniques. And they're still finding new anomalies, details invisible to 1980s technology, patterns that suggest we've barely scratched the surface of what Venera discovered. Between 2028 and 2035, no fewer than 5 major missions are headed to our forgotten twin. We're calling it the Venus Renaissance. NASA Da Vinci, launching 2029, will be an atmospheric probe designed to descend through Venus's clouds while analyzing chemistry in real time. Its spectrometers are specifically calibrated to detect phosphine. It will test the Soviet claims directly. NASA Veritas, set for 2031, is an orbiter equipped with synthetic aperture radar far more advanced than Venera 15 and 16. It will map the metallic snow regions with a resolution high enough to see individual boulders. We'll finally understand what's coating those mountaintops. In 2021, MIT researchers published a study proposing that microbial life could exist as floating colonies in Venus's sulfuric acid clouds. Extreme? Yes. Impossible? Not according to extremophile biology. And here's the Soviet connection. If Venera detected anomalous chemistry at the surface, 900-degree hell, what's happening in the habitable cloud zone? Commercial interest is stirring too. Rocket Lab's Peter Beck has proposed a private Venus mission. Breakthrough Initiatives, the billionaire-funded science group, is considering a life detection probe. Unlike Mars, Venus hasn't been commercialized yet. It's still virgin territory for private space exploration. Geopolitically, China sees Venus as a strategic target. It's closer than Mars, faster return on investment, easier to demonstrate technological superiority. 5 discoveries, 40 years of silence, and a new generation of missions racing to Venus. The real question isn't what the Soviets found. It's whether we're ready for what comes next. If you made it this far, you're part of the crew. Subscribe, hit the bell, and join us as we uncover the mysteries the Cold War left behind.